Welcome to another episode of Quanta Talks. Today we are talking about an emerging technology in our renewable energy sector, floating wind. We're speaking to managing consultant Matt Bowles about the challenges, the potential and the pros of this emerging market. We're recording this during a storm, so we might hear some claps of thunder and some rain, but we're going ahead anyway. Today we're talking about emerging technologies in the renewable energy sector, specifically floating wind. So tell me more about floating wind.
So floating wind essentially uses the same technology as conventional seabed fixed offshore wind in terms of turbines. The only change is that rather than being built on fixed foundations into the seabed, the turbines are deployed on top of floating structures that are then secured in place with mooring lines and anchors. So this obviously has a lot of advantages to bottom fixed offshore wind, which we'll come on to later.
And how long has this technology been around?
So believe it or not, the first floating wind turbine was actually installed in 2009 in Norway, but this was obviously very small scale, very early stage kind of development technology. The first real, in inverted commas, floating offshore wind project was the Hywind project in 2016. Construction began in Scotland, and that was operational from 2017 until now. And again, that was a demonstration project.
Cool. And how much power are they currently producing?
Now, that is a good question. So currently there's about 100 megawatts of floating wind project in operation.
Okay, so the potential sounds huge. What are the opportunities from like a skills perspective?
Absolutely. If they can get the technology right and prove that it's a commercial concept, then there will be a significant number of opportunities. From a skills perspective, the roles will be relatively similar to fixed bottom offshore wind. However, there will also be new roles created that we wouldn't typically see on a fixed bottom offshore wind project because of the floating foundation structure that's used. So from that perspective, you'll start to see roles around hull and mooring engineering and things like that. So some of the technical roles will be different to what we see on fixed bottom offshore wind, but roles that we would maybe historically see within the oil and gas sector, for example, and because of the floating technology utilised there, could be transferable into floating wind projects, or will be transferable into floating wind projects.
So candidates with transferable skills from the other subsectors of energy can start a career in floating wind.
Absolutely. I think, there's always been an interest from certain areas of the oil and gas market and other energy subsectors in getting into offshore wind projects, and a number of candidates have done that successfully. But in particular with the floating wind technology, it creates some new opportunities for engineers who maybe haven't previously been able to secure a role in floating offshore wind to make that transition because of the skills that they have, as I mentioned, from say hull and mooring roles within FPSO projects, could then be really useful within floating foundation project teams.
So what are the pros of floating wind? So
the pros of floating wind include the fact that projects can be installed in deeper waters because there's no subsea piling needed, and they're on obviously floating foundation structures, which means they can be towed out to deeper water depths, which then in turn means we could see larger projects because they can use a larger area as well, because there's less marine traffic obviously at deeper water depths as well, potentially less environmental impact and less impact on marine life. Again, because there's no kind of pile driving needed to install the jacket foundations for the substations or the monopiles for the actual turbines. That means there'll be less subsea noise and less disruptive kind of environment to marine mammals as well during the construction and installation. Quicker and easier installation as well, because a lot more of the installation work can be done kind of in port or on the quay side before the foundations are tugged out with the turbines attached. So it will mean that once offshore, all that needs to happen is the connection of the cables, the connection of the substation, and commissioning. So it should make life easier in the future. It also opens up new locations as well.
So where will we see these projects if it's opening up new locations? Where will we see them in the future?
Sure. So a lot of the locations will be the same as fixed bottom offshore wind, but potentially kind of different areas of the same country, if that makes sense. But it will also open up kind of completely new territories as well. So because somewhere that might not be suitable for fixed bottom due to the limit on water depth or the actual water depth in that location. So Cornwall in the UK, Wales, the Celtic Sea, certain areas of Scotland, the west of Ireland, the west coast of the USA, Norway, and also certain locations in APAC as well.
Cool. So that's exciting to see new locations and potentially open up them skills for other candidates as well that live in those areas. What challenges are the wind sector facing in general?
So the general offshore wind market is facing a number of challenges at the minute, and that is, a byproduct of a really booming industry at the moment, I think. Now, floating obviously is going to face these challenges as well, but it does have its own kind of unique ones as well, much like any emerging market or, technology does. But the general offshore wind market at the moment is facing a potential skill shortage. So the volume of projects versus the available suitable personnel, supply chain challenges as well. So, for example, the availability of steel and kind of fabrication yard space to actually produce and store all of the monopiles or the jacket foundations that are needed in transition pieces. And then also on a more regulatory and governmental level, there are challenges around kind of consenting timescales as well for these projects to actually, then deliver power by when they kind of have said they'll deliver and when governments have committed to have set number of gigawatts installed. All of these challenges have a knock-on effect.
You mentioned there are specific challenges to floating wind. What would they be?
Yeah, so obviously it's a new technology. So as I mentioned at the start, the deployment of the technology is on a much smaller scale at the moment to try and demonstrate that it works both technologically and commercially. Commercially, one of the big things that the industry is driving towards is obviously cost reductions and creating economies of scale. Recently supply chain issues have seen both Shell and Equinor either cancel or delay floating wind projects. Technically, you've got things like obviously the stability of a floating platform with a rigid kind of turbine structure on top. So how are these floating structures going to deal with adverse weather? And how are the foundations going to respond to motion due to the environmental factors? Obviously, the deeper out to sea you get, the choppier the water can be, the higher the wind speed is, which obviously is a huge advantage of the technology, the fact that it can be deployed in a higher wind speed area. Port infrastructure, that also needs to be amended to allow for floating wind and the increased kind of port side or quayside construction that these projects bring. Up to now, the lack of port infrastructure has potentially made concrete look to be a more attractive option over steel for the floating foundations as its core material, because obviously it's easier to manufacture concrete structures. The structures only kind of require the molds and then the raw materials, not the specialised welding equipment or specialised skilled welders that the steel ones do. Obviously, steel fabrication, it adds risk to a floating wind project as well because it requires additional transport of large components, which could increase cost and carbon footprint. However, obviously within the fixed bottom world, all of the foundations are, milled steel monopiles. So I think that's something that can be overcome. But the steel floating structures are much more complex from a welding perspective and a fabrication perspective. So it's definitely something that the industry is obviously trying to assess at the moment in the kind of commercial projects that we're seeing.
Cool. So there's a few things to overcome, but I'm sure offshore wind, fixed bottom had all of these potential challenges when it first, started.
Exactly. Any new technology or new industry has, challenges that it has to overcome. And I think what's really good to see is, in an industry like floating wind, is whilst it is obviously very competitive as to, who wants the rights to what zone or what project to develop, there's also a lot of cross-industry kind of partnership and ventures out there to, make sure that the industry collaborates, shares knowledge and shares information to kind of, reach a common goal. And hopefully that will be identical in floating wind as well.
Excellent. So obviously, you've worked on projects before with some of our clients, and we've supplied technical skills to these projects. How are we continuing to support floating wind sectors?
Sure. So we've been speaking to clients within the floating wind sector since kind of 2018. And as you mentioned, we've worked on a number of kind of floating specific projects to date. And really for us, it's a key market that we want to be a go-to supplier in. We've already got a really well-established offshore wind team that's focusing on fixed bottom. We're now also developing a team purely focusing on floating wind projects because of the size and scale of the opportunity. So, we're supporting clients at the moment across UK and European projects, specifically focused on kind of during that feed stage. And then obviously as the projects go into construction and commissioning, we'll then obviously kind of utilise our experience in that.
So what is the potential of the floating wind market?
So the floating wind market has the potential to be huge. It's really exciting. So technically, the technology is thought to be viable from, water depths of 50 metres to 1,000 metres. So it really opens up such a huge kind of portion of the ocean and, geographical territories where this market can go. Some of the major developers in fixed bottom offshore wind who are now looking into floating offshore wind are citing that up to 80% of the world's offshore wind resource could be kind of taken advantage of or capitalised on by the use of floating wind technology. Based on current estimates, it's not unfeasible to think that there could be up to 10 gigawatts of floating wind in operation by 2030. Now, that's obviously going to need to, or that's going to be based on making sure the right policies are in place at governmental level, that, the supply chain can deliver, that the port infrastructure is available. But there's a real excitement about this market. Inevitably, it has some challenges, but it has a lot of pros, and it really could be a game changer for offshore wind and energy generation in the years to come.
If you would like our support on your next renewable energy project, please contact us on Quanta Talks at quanta-cs.com. Thanks for listening.